This is the data collection demonstration video for the Resistivity lab of Physics and Engineering 217. And in this lab we're going to be looking at the resistive properties of 3 distinct wires. And for each of those we're going to collect 2 sets of data. One where we're looking at the voltage drop across the entire wire as a function of the current we're applying through that wire. And for our second set of data, we'll be looking at the voltage drop across a section of wire as a function of how long that section of wire is for some constant current. So those are the 2 main sets of data we'll be collecting for each of the 3 wires. Then there's some additional analysis that your team will need to complete for those. So that's the basic overview for the lab. We can now take a look at some of the equipment and setup we have available to accomplish this.
So here we're going to cover the basic setup and equipment we have for this lab. We will end up taking a couple different sets of data, one looking at that voltage and current relation, one looking at the voltage drop as a function of length relation. So the setups that we'll use for those 2 different data collection bits might be a little different, but we're going to cover the general setup and the equipment here first. So the first and foremost, we have this resistive wire board here. And this is just a board with 3 different wires stretched across the length of the board. And on either end we have binding posts, which are just a type of connector we can hook a banana cable up to. For consistency in this lab, we're going to come over here and just label these wires 1, 2, and 3, just so throughout the course of this experiment we'll consistently refer to them by the same designation here. So we'll always call that top one wire 1, the bottom one wire 3, just to keep things straight. So after our resistive wire board here, the next piece of equipment we have is our power supply, which we're going to use to provide that current or voltage depending on the experiment that we're going to be setting up there, and a couple of banana cables that we'll just go ahead and hook up to channel 1 here on the power supply. We have a couple other kinds of cables here, since for part of this lab we'll be using the DAC. We have a BNC to banana cable that we can hook up to the DAC to take measurements, and we also have this cable here, which is a test clip. And for a bit of a close-up view on that, this test clip just has a little hook at the end that we can directly attach to any of these wires. So that way we can take a voltage measurement at any point along any of these wires here. So we're going to take these 2 cables, our BNC to banana and our test clip, hook the test clip up to the BNC to banana, and then we will come over and attach that to the DAC. For our purposes here today, we'll just hook this up to channel 0. And set the cable up there till we're ready for that later on in the lab. The last 2 bits of equipment that we have here are fairly straightforward. We have a meter stick, since we'll want to be looking at length and the length of these wires. We can use our meter stick for that. And we also have a pair of calipers. So if you may not have used one of these before, a pair of calipers is just a device for measuring distance, but it will be measuring the distance as the separation between the jaws here. So if we turn it on, for example, and stick a finger in there in measurement, we have about 12 millimeters would be the width of the finger there. So we can use that to find the diameter of these wires later on. So that's all the basic equipment we have now. We can now go ahead and take a look at actually collecting some of our data for this lab.
So here we're going to cover the data collection for the first of those data sets we're looking at here, where we're going to look at the relation between current applied through the wire and the voltage that we measure across that wire as well. So for our setup here, going to be real basic. We're just going to take our red banana plug, plug it on the red binding post, and our black banana plug, and put it on the black binding post. For this data collection here, we're just going to demonstrate on wire 1, but we'll repeat this same process for the 3 different wires that we have here. So that's all that we have for the setup there, and now we're going to pop up over to our power supply, since this is where we'll actually be taking the measurements from. We're not going to use the DAC for this part of the lab. We're going to do everything with the power supply here and just using Excel. So here we can set our voltage and our current caps. So as per the lab manual, we're going to set that current cap to 0.1 amps. And then for the voltage, since we want to specify the current and measure what the voltage is, we're just going to set this voltage as high as the power supply goes, which for these on channel 1 is 6 volts. Great, so we're all set there. Now we're going to turn this on. So now we have our first pair of measurements. We have 0.1 amps produces a voltage drop of 0.6 volts across wire 1 when we're in constant current mode here. So now if we pop over to Excel here, we can just start taking our data. So we'll specify current and voltage. So here we have 0.1 amps produces a voltage of 0.608 volts. Now we can step this down and we'll take our next measurement. So here we'll go from 0.1 amps to 0.09 amps. And then we have our next data point that we can record here. So that'll be 0.09 amps and 0.547 volts. Then we're just going to repeat this till we're all the way down to 0. So we should have roughly 10 data points there. And we'll repeat the same process for wires 2 and 3. And we'll supply all of these 3 files in a specific folder on the current versus voltage relation, and we'll have a second subfolder for the next set of data we'll be taking here. So here we're going to look at collecting data for our second part. So here we have basically the same setup we had used before, where we have our power supply hooked up across our resistive wire board here. And for all of these measurements we're going to be taking, we're going to set the current here to 0.1 amps. So that's the same current we're going to be using for all data points we take across all 3 wires here. So the only other change we're going to make to our setup here, in addition to having our meter stick up here, is we're going to take our 2 cables that we have coming from the DAC and hook them up here. So we're going to start with our black cable tied to the black coming out of the power supply. So we're just saying that 0 is the same across the DAC and the power supply. We're tying our grounds together. And then we're going to take our little test clip here, and we're going to hook that up to the wire as close as we can get it to the black end. So we're going to start from this end and work our way over, and we're going to say that that's essentially 0 for this first measurement, the length of the wire we're measuring, since that's as close as we can get it to that wire on that end. So now if we pop over to our terminal, we can list out the contents of this example's DAC directory here. And the script we're going to be using in here is this DAC to CSV with input script. What this will do is take measurements from the DAC as a function of some value we're supplying, some independent variable we're specifying. So that could be mass, current, whatever given the application for the lab. Here we're going to be saying for a given length, and then it will measure a corresponding voltage measurement. So we're going to open that up here, take a look at this variable section. We only have 4 here that we can play with. So n is the number of individual DAC readings that will be taken and averaged together for one data point. So this default 1000 we can leave there just fine. Channels is what DAC channels we'd like to read from. Here, since we have our cable hooked up to channel 0, we're just going to specify channel 0. Points is the number of different measurements we can take. So this is the number of times we'll be prompted, and it will measure a corresponding DAC value. So here, since we have 3, if we were to leave that, we could take 1, 2, and 3 measurements, which wouldn't give us a lot of data here, so we're going to up this. So our overall wire length is about 700 millimeters, and we can take a measurement about every 50 millimeters. So let's go ahead and put 14 in for this value here. And then for our file name, we'll just want to give this some descriptive name. So this is our voltage versus length run, and for this first one, we're going to be looking at wire 1. So we're going to save all of those changes, and now we're ready to go about taking some data. So we'll clear up our terminal, and then we'll launch that script with this Python 3. So here we're prompted to enter what's the independent variable we're changing. So for our purposes here, that'll just be length. And the units we're using for this are going to be millimeters. So now we're ready to start taking some data points. So again, since we're as close to that black end as we have there, this is essentially as close as we can get to a 0 measurement. So we'll enter 0 there. It takes those 1000 readings, averages them together, and gives us a measurement. So now we can move on down the line. So we have our 0 measurement. So we'll move that over from the 700 mark to the 650 mark. So we'll say this is our 50 measurement. It'll take those values, we'll slide on down the line to the 600 mark. So now we're 100 millimeters down. We'll take our next measurement, etc., as we go down the line here. So this would be our 150. And we'll go ahead and take the rest here. Alright, it Looks like we're approaching the end here, so we'll take a measurement at 650, and it shows our data collection is complete there. So now if we list out the contents, we say we have this new V versus L wire 1 value here. And we'll quickly just open it up in the terminal to take a look at it. It won't be nicely formatted like it will be when you open it up in Excel or something like that. But if we open it up, we see that we have a 3-column CSV here. So the first column is that length that we measured in millimeters. The second column is the voltage measured from the DAC, and the third column is just the uncertainty associated with that voltage measurement. So we'll perform the same measurements for wires 2 and 3 off camera, and we'll provide each of those as a part of the data available for the analysis in this lab.